So this equations for this rate equations for forward reactions, rate equations for the backward reactions. And if you consider these general reactions, A is form B and B again is formed into the A. This is the main reaction and this one is the reversible reactions, right? So both are the reactions are very important to find out the rate equations or the rate of reactions. So what is the role of this reversible reaction? It is disturbing the reactions, main reactions, right? So therefore all these reactions it is called as the disturbing factors. All reactions it is called as the disturbing factors. So if you know the equations or the rate equations for this reversible reactions, then and only then you can find out the exact rate of equations or the rate of reactions for this main reaction. This was the uh, reactions for this, that is the reversible reactions. This is the rate equations for reversible reaction. Yesterday we have derived these equations also, right? So today we are going to talk about the next reaction. It is a one kind of reaction, that is the simultaneous kind of reaction, that is the side or parallel reaction, right? So what is mean by the side reactions or the parallel reactions? The reaction, those reactions which the reacting molecules, one or two reacting molecules which reacts or decomposes while they're performing the reactions. जेव्हा त्या reactions perform होत असतात त्यावेळेस तो react होईल किंवा decompose होईल. The reactant molecule एक असेल, दोन असेल, तीन असेल. So that time, while performing their reactions, it is reacts or decomposing, it is in more than one way and it gives the different products, different set of products, right? For example, if you consider a general reactions, if you consider a general reactions, we are going to take general reactions, right? So for example, A is the product, A is the reactant molecules, and this reactant molecule, it is transformed the three product or it is converted into three product. So for example, B, C, and D. So A is converted into B, into C, into D. So this is the reactant molecules, right? So this reactant molecules, it is converted into this three product. It is converted into three products. So this three product, it is obviously, this is the pathway 1, pathway 2, and this is pathway 3. So in this way, the three ways to conversions of the three products, right? So this is called as the side or parallel reactions. The reactant molecules or those reactions are, the reactant molecules are decomposing or it is reacting or it is performing their reactions in more than one ways, or more than one path. So, and it gives the different set of products, 2, 3, 4, 5. Okay. So this is reactions. It is called as the parallel reactions or side reactions. So in these reactions, the reactions giving the maximum and minimum product. So suppose if you consider the B is 80% yield, C is the 15% yield, and D, this product, it is only 5% yield. Okay. So this is the major product and these two are the minor product. These two are the minor product, right? So this major product, it is called as the main reactions. It is called as the main or major reactions. And the path 2 and path 3, it is the simply called as the side reactions. It is simply called as the side or parallel reactions. It is called as the side reactions or the parallel reactions. So such a reactions which is disturbing to the main reaction. These two reactions are disturbing to the main reactions. That reactions it is called as the side reactions or parallel reactions. डिस्टर्बिंग करतंय म्हणजे नेमकं काय करते, तर याचा जो रेट ऑफ रिएक्शन्स आहे तो रेट ऑफ रिएक्शन्सला तो अफेक्ट करतोय. अँड आपल्याला माहित आहे की रेट ऑफ रिएक्शन्स, व्हॉट इज द रेट ऑफ रिएक्शन इज प्रोपोर्शनल टू, इट इज प्रोपोर्शनल टू कशाशी प्रोपोर्शनल असतो रेट ऑफ रिएक्शन्स, इट इज प्रोपोर्शनल टू द डिफरंट फॅक्टर्स. कशाशी, तर टेम्परेचर, प्रेशर, कॉन्सन्ट्रेशन्स अँड कॅटॅलिस्ट याच्याशी तो प्रोपोर्शनल असतो. जर टेम्परेचर इन्क्रीज केलं तर रेट ऑफ रिएक्शन इन्क्रीज होते, प्रेशर इन्क्रीज केलं तर रेट ऑफ रिएक्शन इन्क्रीज होते, कॉन्सन्ट्रेशन इन्क्रीज केलं तर रेट ऑफ रिएक्शन इन्क्रीज होते, कॅटॅलिस्ट असेल. So we know that the catalyst, it is that this is not directly taking part into this chemical reactions, but the catalyst, it is the positive catalyst. If it is the positive catalyst, it is increase the rate of reactions. But if it is the negative catalyst, it is decrease the rate of reactions. But we don't consider this one. Okay. So catalyst always increase the speed of reactions, and after the reactions, it will be remove or it is expelling it. Okay. So this is the proportionality of the rate of reactions. So due to simultaneous reactions or the side reactions or this parallel reactions which will disturbing the rate of reactions, the main reactionच्या रेटला तो काय करतो, डिस्टर्ब करतो. आणि म्हणून याला आपण काय म्हणतोय, साइड सायमल्टेनियस रिएक्शन्स. आणि त्याच्यातलो सेकंड टाइप म्हणजे आपण काय करतोय, पॅरलल रिएक्शन्स. पॅरलल रिएक्शन्स म्हणजेच का, कारण ही रिएक्शन्स होत असताना ह्या दोन्ही रिएक्शन सायमल्टेनियसली होत असतात, पण द पाथवे इट इज, the mechanism of this reactions which will be formed, it is different because the product is B is different, C is different, and D is different. Therefore, the mechanism of this reactions, the path is different, and therefore, this is the disturbing the rate of reactions of the main reactions. आपण एक्झाम्पल बघूया, त्यावेळेस तुमच्या अगदी व्यवस्थित लक्षात येईल. सो suppose this reactant molecule is react and undergoes this three types of the product, and this three type of product which will be this 2 and 3, this is disturbing to the product 1, that is the path 1, and it is called as the main reactions. This is very simple things which will be happen in the side and parallel reactions, right? And this is known as the side reactions. These two reactions, remaining two reactions, it is side reactions. So on the basis of this one, we consider and we can find out the rate equations or the rate constant for this one. The rate equations याच्यासाठी आपल्याला, तुम्हाला युनिव्हर्सिटी सिलेबस मध्ये फक्त तुम्हाला रेट इक्वेशन्स कशाचा आहे, फर्स्ट रिएक्शन दॅट इज दी रिव्हर्सिबल रिएक्शन्स. बाकी रिएक्शनचा रेट ऑफ रिएक्शन्स किंवा इक्वेशन्स तुम्हाला विचारणार नाहीये. बट जस्ट टू sake of convenience to understand the concept, we just see what is the rate equations for this reactions. या रिएक्शनचा रेट इक्वेशन्स काय असू शकते विचारणार नाहीये, पण आपल्या समजण्यासाठी आपण ते बघणार आहोत की व्हॉट इज द रेट इक्वेशन्स फॉर दिस रिएक्शन्स. ओके. फक्त फर्स्ट रिएक्शनचा रेट इक्वेशन्स तुम्हाला विचारू शकतात. So if you consider the A is the reactant molecule which will consider the product B and C. Okay. So this is the path 1. So this is your main reactions, path 1. This is path 2, and this is your side reactions. ही तुमची side reactions आहे. Suppose this one is the 895% yield, and this is one is the 5% yield. Okay, just like this one. So this is rate equations काय असते, minus dc upon dt, right? So this is your rate equations or the rate law. Minus sign indicate that the decreasing the concentration of the reactant molecules with respect to time, right? So this is the rate equations. So for example, if you consider the rate equations for the product B साठी जर असेल तर rate equation D concentration of B upon dt. Okay, minus sign नसणार आहे, कारण मायनस साइन इंडिकेट काय, डिक्रीजिंग द कॉन्सन्ट्रेशन ऑफ रिएक्टंट मॉलिक्यूल. हा फॉर्मेशन्स आहे, तो मायनस साइन नाही आहे. त्यामुळे डी ऑफ कॉन्सन्ट्रेशन ऑफ द प्रोडक्ट बी विथ रिस्पेक्ट टू टाइम इज इक्वल्स टू द K1 कॉन्सन्ट्रेशन ऑफ ए. कशापासून तयार होते, तर कॉन्सन्ट्रेशन ऑफ ए. सो दिस इज वन इज. And for the product B, D of concentration of C upon dt is equals to K2 into concentration of A. Again, it is formations with the from A, concentration E. Okay, so this is the rate law for this two product which will be formed in the reactions, right? Now, the overall rate of disappearance of A is the overall rate of disappearance of this one. याला आता आपण सेपरेटली याच्या आणि याच्यासाठी रेट लॉ फॉर्म. So the overall reactions or disappearance of this concentration of reactant A is now minus d of concentration of A upon dt is equals to the K1. It is the simply formations, or it is a simply the decreasing concentration of K1 for this one, okay, and K2 for this two, this, okay. So K1, it is again the concentration of A plus the concentration of K2, the concentration of A, right? So both are the same things. This will be happen. So it means that K1 plus K1 plus K2 into concentration of A. So concentration of A आहे म्हणून आपण तो बाहेर काढू. Okay. So this is the overall disappearance of the concentration of A in both the reactions. Okay. So if you taking the ratio of these two equations, for example, तर आपण दोन रेट्सचा, ह्या दोन रेट्सचा जर काय घेतलंय, टू रेट्स, ह्या दोन रेट्सचा जर आपण रेशिओ घेतला असेल, तर व्हॉट इज द इक्वेशन्स फॉर दिस वन, याचा रेशिओ जर घेतला तर काय होईल, that is K1 upon this concentration of A upon K2 into concentration of A is equals to, so D into D of concentration of B into dt, here dt upon D of concentration of C upon dt. So this A get cancelled, which will be formed. It is the K1 upon K2, this one. This is the equation number 1, and this is equation number 2. The D of concentration of B dt upon D of concentration of C upon dt. So this is your equation number 2. So if you consider this equation 1 and equation 2, we'll get the exactly the individual rate constant for this individual for B and C and A also. So this will be the simply, so just we understand this one again. I just share the here one more conveniently. We see this one. Okay, this competing or this parallel रिएक्शन्स, आता ही जी साइड रिएक्शन ज्याला आपण म्हणतोय, किंवा दिस रिएक्शन्स, इट इज दी पॅरलल रिएक्शन्स, ही जी रिएक्शन्स आहे साइड रिएक्शन्स किंवा पॅरलल रिएक्शन्स, ही कॉम्पिटिटिंग रिएक्शन सुद्धा आपण याला म्हणतोय, कारण ते कॉम्पीट करते. ओके, सो दिस वन द मायनस डी ऑफ कॉन्सन्ट्रेशन ए अपॉन dt इज इक्वल्स टू दिस वन, जे आपण आता काढलेलं आहे त्याला आपण यानी डिनोट करतोय. सो दिस के ऑफ AV, एव्हरेज रेट ऑफ कॉन्सन्ट्रेशन ए, आणि आपण त्याला डिनोट करतोय, राईट. सो इफ यू K1 and K2, इट इज अ फ्रॅक्शनल यील्ड ऑफ B and C, जसं आपण मगाशी बघितलंय, फ्रॅक्शनल यील्ड. सो ऍट this positions, the fractional yield will be this one, and it is considered as this is the main reactions, and it is always give the major product, and therefore the rate of reaction this will be always greater than, and therefore we can write it here K1 is greater than K2, आणि म्हणून K1 काय आहे, K2 पेक्षा जास्त असणार, right? So if this K1 and K2 is greater, so A converted into B is its main reaction. ऑब्विसली ती असणारच आहे का, कारण बी हा जर जास्त तयार होत असेल तर ऑब्विसली त्याचा रेट ऑफ रिएक्शन काय असणार आहे, जास्त असणार आहे, आणि सी चा कमी असणार आहे, म्हणून त्याला आपण साइड रिएक्शन्स म्हणतो. सो लेट आफ्टर डेफिनेशन्स ऑफ युअर इंटरवल x mole per liter of B and y mole per liter of C, then form this x upon y equals to K1 upon K2, this one, and that is the D of concentration B upon dt upon D of concentration of C upon D. So आपण जर त्याला x आणि y कन्सिडर केलं असेल तर this will be happen like this and equals to K1 upon K2. जसं आपण तिथे काय काढलाय, रेशिओ काढलेला आहे, जो पहिल्या स्लाइड वरती बघितलेला आहे की तो that is the ratio. So it means that what is the irrespective of how much time is elapsed, so the ratio of concentration of B to that the C from the starting, and it is assuming that the number of B and the C in the beginning it is constant equal to K1 upon K2. तर जसं तुम्ही इथे बघितलं असेल, तर दिस इज द सिंपल लॉ which will be we can understand with the help of this plot, right? So this line, it is the for the reactant molecule A, okay, and this line, it is the for the reactant B and C. So this is indicate that the decreasing concentrations with the respective time of a reactant molecule A, the simultaneously, which will the formations of the product C and B. So obviously this increasing the product of this with the respective time, but this is the difference between this C and D. The product it is major this one, and this plot shows the less product of a C, and therefore it is called as the side chain reactions. So this is will be indicate that जे आपण म्हणतोय ते तिथे आपण फक्त काय करतोय प्लॉटनी ते दाखवतो. ओके, नाव the examples of the parallel reactions. आता इथे तुमच्या लक्षात येईल exactly what will be the happen, right? So this is an organic compounds and which will be is called as the phenols. And if is the nitrating nitrations, आपण जर त्याचं नायट्रेशन्स केलं तर दोन प्रॉडक्ट आपल्याला मिळतात. जनरली एक असतोय ऑर्थो प्रॉडक्ट आणि दुसरा असतोय पॅरा प्रॉडक्ट. So the ortho product it is main product and para product it is a side product. And this reaction is performing this is the rate for this one it is K1 and this is proportionality constant that is rate constant that is K2. ओके, आता ह्या रिएक्शन्स वरूनच तुमच्या लक्षात येते की असं का होते बिकॉज this product it is more stable than that of this one and therefore this is the हा more stable का असतो कारण इथं हायड्रोजन बॉन्डिंग होते आणि त्यामुळे if it is presence a hydrogen bonding between these two therefore it is a major product. आता हायड्रोजन बॉन्डिंग कसं होते हे तुम्हाला सांगायची गरज नाहीये. ओके, you are very well known the hydrogen bonding how will happen. And thus hydrogen bonding gives the strength of this product and there will the increase the stability of this product and therefore this is the product it is a main product than that of this one. Okay, so we know that the exactly how the organic chemistry behind it, right? ते मी तुम्हाला सांगत बसणार नाहीये. So this is more stable and therefore it is a main product and this is less stable than that of this and this is the side reaction. Okay, and this is an examples of your parallel reaction. Second examples, it is just a similar examples. This is your benzene and the chlorination of benzene. It is very difficult things. This is not a simple task. बेन्झीन वरती कुठल्याही क्लोरिनेशन ब्रोमिनेशन किंवा आयडेनेशन करायचं असेल इट इज नॉट अ सिम्पल टास्क बिकॉज दिस इज द सीएल मायनस अँड सीएल प्लस ही जी रिएक्शन्स होते ही एवढी सिंपल रिएक्शन्स नाही. पण तरी पण आपण असं कन्सिडर करतो की जर क्लोरिनेशन होत असेल सो इट इज अ टू डिफरंट वे अँड इट गिव्स द टू डिफरंट प्रोडक्ट्स. Okay, so this first product it is the chlorination that is a chlorobenzene and second product it is the hexachlorobenzene. It is hexachlorobenzene and this is the side reaction and this one is the major reaction. Okay, so this is a substitutions reaction and no doubt this is also the substitutions reactions, but this reaction is a major product, this reaction it is a less product via two different mechanisms and therefore the rate of reactions for this reaction it is different, the rate of reactions for this reaction is different and therefore denoted by K1 and K. So this is all about the your rate of reactions or the examples of the this parallel reactions. The next examples for this one that is simply we C2H5 Cl plus KOH. So this is the reactant molecules and it reacts with each other and it is formations of two different products. That is the two different product with the two different ways K1 and K2. It is the rate constant for these two reactions and it will form C2H5OH and C2H4. So this one is the major product, this one is the major product, and this one is the minor product. So if it is the minor product, so it is a side chain reaction or side reactions or the parallel reactions. So in this way, it is the formations of this again the alcohol molecules. Alcohol molecules. I just is wash out this one. Alcohol molecules. So this alcohol molecules, it is form three different products, right? So which one? First one, that is it is formations of this your ethylene, right? Plus H2O. Second one, that is a K1, K2, and K3. The second product which will form the aldehyde, and third one it forms the C2H5, OC2H5. So these are the three products which will be formed. And out of this one, this is the main product. This is the main product, and these two are the side product. So all these examples, या सगळ्या एक्झाम्पल्स वरून तुम्हाला असं यू केम टू नो दॅट इज तुम्हाला असं लक्षात आलं असेल की साईड प्रोडक्ट किंवा जे काही मायनर प्रोडक्ट असतात त्याला आपण साईड रिएक्शन्स किंवा पॅरलर रिएक्शन्स म्हणतो. दॅट रिएक्शन्स ह्या काय असतात, त्याचे प्रॉडक्टच हे अनस्टेबल असतात. तुम्हाला हे लक्षात आलं असेल की जे काही अनस्टेबल प्रॉडक्ट असतात ते कमी प्रमाणात तयार होतात कारण ते अनस्टेबल असतात. ते कुठलीही ऑर्गॅनिक रिएक्शन्स होत असताना प्रॉडक्ट हा स्टेबल असावा लागतो. ओके, म्हणून तर आपण रिएक्शन प्रोफाईल दाखवतो आणि असं दाखवतो. ओके, इथं रिएक्टंट असतो आणि इथे प्रॉडक्ट असतोय का, तर याची एनर्जी कमी असते. एनर्जी कमी असते म्हणजेच प्रॉडक्ट हा नेहमी काय असतो, रिएक्टंट मॉलिक्युल पेक्षा स्टेबल असावा लागतो. देन अँड ओनली देन इट विल बी फॉर्म, राईट. सो दिस इज द कायनेटिक्स. हीच तर याच्या पाठीमागचं कायनेटिक्स आहे की याची याची जी एनर्जी असेल ही ऑलवेज इट इज द लेस. ही एनर्जी प्रॉडक्टची एनर्जी ऑलवेज लेस असायला पाहिजे. म्हणजेच काय असायला पाहिजे, आता याचं जर आपण कन्सिडर केलंय द कायनेटिक प्रोफाईल, तर ते कसं असणार आहे, इथे जो प्रॉडक्ट असेल तो तुमचा हा K1 असेल. सपोज आपण याला ए म्हणूया. इथे जे प्रॉडक्ट असेल तो काय असणार आहे, बी असणार आहे. इथे जो प्रॉडक्ट असणार आहे तो सी असणार आहे. सो एनर्जी ऑफ दिस प्रॉडक्ट इट इज डिफरंट दॅन दॅट ऑफ दिस वन. सो मोर less energy, it is a more stable. This is more stable product than that of these two. So therefore it is a formations, it is a minor amount, and therefore it is called as the side or parallel reactions. So this is the exactly kinetics which will be happen in this case. Okay. So therefore it is main product and this is the side product or the side reactions, and therefore it can be the kinetics for rate of reaction for this one. It is different K1, K2, and K3. So in this way, the different types of examples are putting in the syllabus. तुम्ही कुठलेही examples घेऊ शकताय जे तुम्हाला वाटतंय त्या पद्धतीने ते एक दोन तीन एक्झाम्पल्स व्यवस्थित करून ठेवायचे. ओके, सो दिस ट्रू एक्सप्लेनेशन्स विथ द साइड or the parallel reactions. So this all the side reactions or parallel reactions, so velocity of side reactions can be made or it is very negligible by existing the reactions conditions. तर हा जो रेट ऑफ रिएक्शन्स असतोय हा जरासा यांच्यामध्ये थोडासा काय असतोय, फार डिफरन्स नसतोय, तो ऍडजस्ट होऊ शकतो विथ द हेल्प ऑफ सम रिएक्शन्स कंडिशन्स वी कॅन बी चेंज. आणि त्या जर चेंज केल्या करू शकत असेल तर त्या रेट ऑफ रिएक्शन सुद्धा तो चेंज करतोय. ओके, so this is all about the side reactions or the parallel reactions. The next one, that is the consecutive or successive reactions. Consecutive or successive reactions. या consecutive or successive reactions मध्येच तुम्हाला काय येतोय, consecutive reactions. Consecutive reactions or it is called as successive reactions, right. सो कॉन्सिक्युटिव्ह और सक्सेसिव्ह रिएक्शन्स म्हणजे कंटिन्यू होणाऱ्या रिएक्शन्स. सो consecutive or successive reactions means the reactions which will proceed or perform or from the reactant molecules to the product through the different or more than one intermediate formations or intermediate stages will be formed. That or such a reactions, it is called as successive reaction or consecutive reactions. Such a reactions it is called as consecutive reactions. For example, A पासून B तयार होतो, पण B वर तो थांबत नाही. B पासून परत C तयार होतोय, परत तो C वर थांबत नाही, परत C पासून D तयार होतो. So these are the two are formations of intermediate. Formations of intermediate. So this intermediate stages which will be formations in the reactions, such reactions it is called as successive reactions or consecutive reactions. त्याला आपण successive reactions म्हणतोय किंवा consecutive reactions. मोर दॅन वन, एकापेक्षा जास्त इंटरमिडिएट पाहिजे, 2 3 4 5 6 अशा अशा ज्या रिएक्शन्स असतात त्या रिएक्शन्सला आपण काय म्हणतोय, consecutive reactions or सक्सेसिव्ह रिएक्शन्स. फॉर एक्झाम्पल, आता याचा जर कायनेटिक्स असेल तर प्रोपोर्शनॅलिटी कॉन्स्टंट और रेट कॉन्स्टंट दॅट इज K1, that is K2, that is K3. So this the substance A is converted into B or into converted into directly C. So through this intermediate that is B, and if you consider this A, B and C or D, so this is the consecutive reactions, and the having the rate constant that is K1, K2 and K3. So then in this reactions each stages has its own velocity, and the velocity constant for this the reactions it is, and the order of reactions is determined for the slowest reactions which will be called as RDS, rate determining steps. म्हणजेच आता या सगळ्यांचा जर तुम्हाला ओव्हरऑल रेट ऑफ रिएक्शन्स काढायचा असेल, कारण ह्या सगळ्या सायमल्टेनियस रिएक्शन्स नाही आहे, हे कंटिन्यू होणारे रिएक्शन्स आहे. तर रेट ऑफ रिएक्शन्स याचा वेगळा असणार, या रिएक्शन ए पासून बी तयार होणारा वेगळा रेट ऑफ रिएक्शन असेल, बी पासून सी तयार होताना रेट ऑफ रिएक्शन्स वेगळा असेल, सी पासून डी तयार होताना रेट ऑफ रिएक्शन वेगळा असेल. सो ओव्हरऑल रेट ऑफ रिएक्शन्स आपल्याला जर काढायचं असेल, विच विल बी डिटरमाइन द रेट ऑफ रिएक्शन्स फॉर अ consecutive or successive reaction, then that time we can simply overall reactions, rate of reactions can be considered. So that time we consider those reactions which is slower. ज्या रिएक्शन्स काय असतात, स्लो रिएक्शन्स असतात, या तीन पैकी त्या रिएक्शन्सला आपण काय म्हणतोय, RDS, रेट डिटरमाइनिंग स्टेप्स. रेट डिटरमाइनिंग स्टेप्स. ओके, सो दिस रेट डिटरमाइनिंग स्टेप्स ती रिएक्शन्स कन्सिडर करतोय, अँड वी कॅन कन्सिडर दॅट इज द रेट ऑफ रिएक्शन. त्या रिएक्शनचा रेट आपण ऍव्हरेज रेट ऑफ रिएक्शन्स म्हणून किंवा ओव्हरऑल रेट ऑफ रिएक्शन्स ऑफ कन्सिक्युटिव्ह और सक्सेसिव्ह रिएक्शन्सचा आपण काय करतोय, कन्सिडर करतोय. सो दिस इज अ सिंपल वे टू डिटरमाइन द रेट ऑफ रिएक्शन्स. नाउ अगेन आता थोडेसे आणि तुमचं 1 मिनिट राहिलेलं आहे, परत जॉईन व्हा. ओके, मी दुसरी स्लाइड्स हे करतोय, शेअर करतोय. नाउ हियर, so the definitions of this rate of reactions or the consecutive reactions or sequential or successive reaction, it is simply we can say that A to B, B to C and so on, the reactions which will final product through the different or one or more intermediate stages which is called as the consecutive or successive reactions. The examples of this consecutive or successive reaction is this one, right? So decomposition of ethylene oxide. This is the one reactant molecule which will be decomposed and into formations of the aldehyde, right? This acetaldehyde will be formed. This is the K1. Then acetaldehyde, it is converted into this product carbon monoxide and the methylene gas. Okay, so this is the second reaction, but this aldehyde it is an formations of intermediate. So these two reactions, it is considered as a sequential reaction, right? Second example, that is a parallel